The previous episode revealed how another field built an airplane to overcome complexity, achieving both precision and breadth while minimizing the burden. Now we become engineers. We'll adapt their blueprint for psychology, creating a feasible path toward precise and broad studies. Naturally, we can't just copy AI's methods outright. That would be like throwing the baby out with the bathwater. We'd lose the unique strengths we value in psychology. While we're learning from AI, this isn't about adapting AI to psychology, but about adapting AI for psychology. The goal is to use their powerful methodological elements as tools to serve psychology's core goals on our terms. Today, we'll build this optimal approach across 6 methodological dimensions. We'll determine which elements to borrow from AI and where we must stick to psychology's traditional strengths. They use large-scale data sets to achieve breadth. We should adopt this scale, but with a critical modification. Our data should come from controlled experiments. This preserves our fundamental strength in rigorous science, isolating causal relationships and minimizing extraneous variables. In short, we need large-scale controlled experiments. They use quantitative modeling like neural networks to achieve precision. We should adopt this quantitative approach, but with another crucial modification. We need interpretable models, not opaque black boxes. This ensures our models provide mechanistic explanations that advance theoretical understanding, the fundamental goal of our science. In short, we need quantitative, interpretable models. They typically use a stimulus-driven design, sampling from stimulus space. Think ImageNet, a vast collection of real-world images that captures the true challenge of object recognition. We traditionally use a theory-driven design, sampling from factor space. We hypothesize which factors matter for object recognition, then create specific conditions to test them. Their success shows the power of stimulus-driven design for large-scale studies. But this creates a dilemma. If our goal is theoretical understanding, shouldn't theory-driven design be better? Here's the surprising answer, what I call the paradox of theorizing. For gaining theoretical understanding from precise and broad studies, stimulus-driven design is actually more effective than theory-driven design. This paradox stems from the PBS impossible trinity. Precise and broad studies are inevitably complex and involve many factors. Unfortunately, theory-driven designs require us to define all these theoretical factors from the start, a nearly impossible mission that causes such designs to collapse. In contrast, a stimulus-driven design is far more manageable. It uses natural stimulus variations instead of predefined theoretical constructs, thereby avoiding the need to identify all factors at the outset. Simply put, when mechanisms are complex and key factors are unknown, it's better to collect rich data and let it guide us than to impose theoretical assumptions up front. To sum it up, we usually take it for granted that the theory-driven design will be the most suitable for a theory-oriented goal, but it is not. The stimulus-driven design is. If this seems counterintuitive, good, it should. We'll bring this paradox to life with concrete examples in episode 8. So, stimulus-driven design becomes our primary strategy. This is precisely because we often don't know all the relevant factors in advance. But for the factors we do know and can control, we should absolutely incorporate them. This synthesis leads to our optimal design, sampling from a factor-informed stimulus space. While psychology traditionally relies on confirmatory analyses like ANOVA, our new approach requires exploratory, iterative model building. Since we're using a stimulus-driven design, there are no predefined hypotheses to test. This makes exploratory modeling not just useful, but essential. It is, in other words, the engine of data-guided theory building, a process where empirical evidence itself constructs and refines theory. Let's summarize across 6 key dimensions. Our optimal approach aligns with their methods in 3 areas: quantitative modeling, large-scale data, exploratory analysis. It aligns with traditional psychology in 2, theoretical understanding, controlled experiments. And it creates a synthesis for design, sampling from factor-informed stimulus space. Now we have all the pieces for a new methodology designed for precise and broad research. So, we now have our blueprint and all the parts. The airplane is designed and ready to be built. In the next episode, we'll formally introduce this approach, comprehensive exploration. See you then.